What if I told you that your GPU might not be the real problem, even if your games are running worse than ever lately? Because for many people, the actual issue is something they almost never pay attention to when upgrading their system. It's not the raw power of the graphics card itself, but a hidden limitation inside it that most users completely overlook. And that hidden limitation is something called VRAM, which plays a much bigger role than most people realize. Even high-end GPUs can start to struggle when this resource runs out during demanding tasks or modern games. And when that happens, performance can drop very suddenly, even if the rest of your system is still powerful. Games may start to stutter, textures may load slowly, and the entire experience begins to feel noticeably worse. And the worst part is that this problem is becoming more common with every new generation of games and applications. To understand why this matters, we first need to take a closer look at what VRAM actually is and what it does. VRAM, or video memory, is the dedicated memory inside your graphics card that stores the data it needs to work. This includes textures, models, lighting data, and everything required to render what you see on screen. Instead of loading this data from slower storage devices, the GPU accesses it instantly from VRAM. This allows games and applications to run smoothly, especially when dealing with high-resolution graphics. But the amount of VRAM is limited, and once it starts to fill up, things begin to change. When there isn't enough memory available, the system has to rely on much slower alternatives. And that is when performance issues start to appear, even if your GPU is still powerful. As games and applications become more advanced, the amount of data they need to store and process keeps increasing. High-resolution textures, detailed environments, and complex effects all require more memory to function properly. Every element you see on screen needs to be loaded into VRAM before it can be displayed. And as more of these elements appear at the same time, memory usage starts to rise very quickly. At first, everything works normally, and performance remains smooth without any visible issues. But as the VRAM begins to fill up, the system starts getting closer to its limits. Once it reaches that point, even small increases in demand can push it over the edge. And that is when the first signs of performance problems begin to appear. Once your VRAM reaches its limit, the system can no longer store everything it needs to run the game properly. At that point, performance issues start to appear, and they can become very noticeable during normal gameplay. You may begin to experience stuttering, frame drops, or small freezes that interrupt smooth movement on screen. Textures might not load instantly, causing visible pop-in or reduced quality visuals for a few seconds. Even simple actions like moving the camera can start to feel inconsistent, delayed, or slightly unstable. This happens because the system is forced to rely on much slower memory outside of the available VRAM. And that creates a serious bottleneck that limits how fast data can be accessed and processed by the GPU. Which means that even powerful graphics cards can struggle when they run out of available memory. In modern games, VRAM usage has increased significantly, especially with the introduction of higher quality assets. Large open-world environments require massive amounts of memory to store textures and world data at the same time. When you increase settings like texture quality, the demand for VRAM rises very quickly. This is because higher resolution textures take up much more space inside the graphics memory. In many cases, games may start loading lower quality assets first, and then replace them with better ones. This creates visible changes in quality, where textures suddenly become sharper after a short delay. During intense scenes with many effects, the demand becomes even higher and harder to manage. And this is where many systems begin to reach their limits without the user even realizing it. When your system runs out of VRAM, the impact on performance becomes much more noticeable and much harder to ignore. You may start to experience constant stuttering, where movement feels broken and far from smooth in many situations. Frame rates can drop suddenly, even in scenes that would normally run without any noticeable issues at all. Textures may take longer to load, creating visible delays and sudden changes in visual quality while playing. Even simple camera movements can begin to feel unstable, inconsistent, or slightly delayed in response. In more demanding scenes with many effects, the system may struggle to keep up with everything happening at once. This creates a frustrating experience where performance feels inconsistent, unpredictable, and difficult to control. And at that point, it becomes clear that VRAM is no longer just a detail, but a critical limitation. As technology continues to advance, the demand for VRAM keeps increasing with every new generation of games and applications. Modern titles are becoming significantly more detailed, with higher resolution textures and more complex environments than ever before. This means that the amount of memory required to run them properly is also growing steadily over time. Features like advanced lighting, reflections, and visual effects all contribute to higher VRAM usage in modern engines. Even compared to just a few years ago, the difference in memory demand is already very noticeable in many cases. And this trend is not slowing down, but actually accelerating as new technologies continue to improve. Which means that systems already close to their limits today will struggle even more in the near future. And for many users, this is not a temporary issue, but a problem that is only going to become more common over time. But this growing demand for memory is not limited to gaming, and it extends far beyond personal computers. Artificial intelligence systems also rely heavily on large amounts of VRAM to process and store data efficiently. Training modern AI models requires enormous datasets that must be handled quickly and in parallel. This means that GPUs are being pushed to their limits not only by games, but also by advanced computing tasks. In large data centers, multiple GPUs work together, each requiring significant amounts of memory to operate. As these systems become more complex, the demand for VRAM continues to rise across the entire industry. This creates increasing pressure on hardware, affecting both large companies and individual users. And this is why VRAM is becoming one of the most critical resources in modern computing. While large companies can scale their systems using multiple GPUs, most users are limited to a single graphics card in their setup. This creates a significant difference in how much memory is available for demanding tasks and modern applications. In large data centers, workloads can be distributed efficiently across many GPUs working together at the same time. But on a personal system, everything depends entirely on the VRAM available in just one card. This means that hardware limitations are reached much faster when running modern games or complex software. Even if your GPU is powerful, it cannot fully compensate for a lack of available memory in many situations. As a result, performance issues can start to appear sooner than expected during real-world usage. And over time, this gap between personal systems and large-scale infrastructure continues to grow even further. Looking ahead, the demand for VRAM is expected to continue increasing as technology keeps advancing at a very rapid pace. Future games will push graphics even further, with higher resolution textures and significantly more complex environments than today. At the same time, artificial intelligence systems will require even more memory to process larger and more advanced models efficiently. This means that both gaming and computing workloads will demand significantly more resources than what is currently available. Even current high-end hardware may start to struggle when trying to keep up with these future requirements. As systems become more demanding over time, memory limitations will become more noticeable across many different use cases. This is not a short-term problem, but a long-term trend driven by constant technological progress in the industry. And unless hardware evolves fast enough to match these needs, this issue will only become more widespread over time. At this point, it becomes clear that VRAM plays a much more important role than many people initially expect in modern systems. It is not just about raw GPU power, but about having enough memory to handle demanding workloads efficiently. When there is enough VRAM available, everything runs smoothly and consistently without major performance issues. But when that memory is not sufficient, performance begins to break down in noticeable and sometimes frustrating ways. This explains why some systems struggle even when they have relatively powerful graphics cards installed. The limitation is not always the GPU itself, but the amount of memory available to properly support it. Understanding this difference is key to identifying where the real performance problem actually comes from. And once you recognize it, many issues that seemed random suddenly start to make much more sense. In the end, VRAM is not just another technical specification, but one of the key factors that defines performance in modern systems. It directly influences how smoothly games run, how quickly data is processed, and how stable the overall experience feels. As technology continues to evolve, this limitation becomes more important with every new generation of hardware and software. What once seemed like enough memory may no longer be sufficient for future workloads and more demanding applications. And this is why understanding VRAM is becoming essential for anyone using modern graphics hardware today. Because the difference between smooth performance and constant issues often comes down to this single factor alone. And as we move forward, this gap between available memory and demand will likely become even more noticeable. Which means that VRAM is not just part of the system, but a defining element of its future performance.